Hey guys, and welcome back. This note is going to be all about drafts and the language you need to know in order to survive, just in case you come in contact with one of them. Alright, let's go. Hey guys, and welcome back. Subscribe to my channel if you have not done so already. Today we are going to be learning all about drafts. So we're going to be learning a bunch of terminology, starting with how to find a domain and range, to find out when the function is increasing and decreasing, figure out the y-intercept, the x-intercept, figuring out minimum and maximum, relative or absolute. So for that, I have a function that I've drawn already and saved. So I'm going to put it out right now so that we can hit the ground running and get a lot done. Okay, so this is my draft, and we're going to start with the domain. So how do you find a domain when you have a draft given to you? So what we need to know is that the horizontal axis here, the x-axis, is going to be the list of positions, and the vertical axis here, the y-axis, is going to be for the height. So starting with the domain, how do you find out the domain of a function? Well, for that, you need to look at the draft and find out the smallest x possible that's in the function and the largest x possible that's in the function, and get them both and put them into an interval form. So our domain here, if you look on the left side here, since it's an arrow down here, it means that our function goes down forever, which means that our x value goes to the left forever. And so our smallest value for x here is going to be negative infinity, and our largest value is going to be, if you look on the right side here, the fact that I have a dot here means that the function stops and does not go forever. And so that's going to be right here at 7. And so we're going to have the interval negative infinity, comma, 7 as our domain. I'm putting a parenthesis on infinity here to say that that doesn't stop and it goes forever. But at 7 here, I'm going to have to put a closed bracket to say that the draft actually stops at 7, and the location 7 is actually part of our draft. So to find the range, I'm going to do the exact same thing, but looking at the heights. So I'm going to look for the smallest height possible, which is going to be, in this case, negative infinity, because our function goes down forever. And the highest height I can find here is going to be 3, because that's where we're stopping. And again, I'm going to have parenthesis, negative infinity, and then I'm going to have 3 in close parentheses here to say that 3 is also part of our function as a height. The next thing we're going to do is figuring out how to find the interval where our function is increasing. And so for that, looking at this graph here, if you look at our graph and consider it to be a mountain going from left to right always, you're going to be looking at the portion of our graph where you're going up. And so that's going to be from the beginning, from negative infinity, all the way to negative 2 here. And so remember, whenever you're giving interval for increasing or decreasing, you're looking for the interval on the x-axis, because the x-axis is what's giving you the position and the y giving you the height. So for intervals of increasing or decreasing, we're going to be looking at the x-axis only. So although we're going all the way to the point negative 2, 3, our interval is going to be only x values. So we're going to get negative infinity all the way to negative 2. And then from there, we're going to see that the graph also starts going up at 2.5 all the way to 5. And so those two intervals are where the functions are going up. That's where the function is increasing. And I'm going to put open parentheses everywhere here, even at the end points that are not infinity, because at those particular points, the graph is considered not going up, not down. So we're going to put an open there to say that at that particular point, we are stopping. We are not going up anymore, and we are just constant. So we're going to repeat the same process to figure out where the function is decreasing. And as you can see here, starting from negative 2 here on the x-axis, we are going to start going down until we reach 2.5. So our first interval is going to be from negative 2 to 2.5. And our next interval where the function is decreasing is going to be from 5 to 7. Next up, we're going to be writing out our x-intercept. The x-intercept here represents the point where the graph is meeting with the x-axis. So in our case here, you can see that the graph is meeting with the x-axis here, 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 and here. 4 different places. And so all these points have an x-coordinate, and their y-coordinate is going to be 0. It has to be because it's on the x-axis. So we're going to have our first one here as negative 5, 0. The next x-intercept is going to be 1.5, 0. Next one is going to be 3 and 1/2, comma 0. And finally, we're going to get our last one at 6, comma 0. Next, let's talk about the y-intercept. That's where your graph is meeting up with the y-axis. In our case here, we're going to have that at only one position here. That's going to be at 2. So our point here is going to have the x-coordinate 0 and the y-coordinate 2. And as you can see here, your x-intercept are always going to have 0 for y-coordinate, and your y-intercept are always going to have 0 as your x-coordinate. Next up, let's talk about minimums and maximum. First thing we should talk about are relative maximum or local maximum. The word relative and local can be used interchangeably. So if our graph here represents a bunch of mountains, a bunch of hills and valley, then our relative maximums is going to be found at the top of every mountain in our graph. So in this case, since we have two highs here, we're going to have two relative maximum. One that's going to be at -2, 3, and the other one is going to be at 5, 1. And the way you read this point is you're saying that you have a relative maximum at -2, and the relative maximum is 3. And the next one here, you say you have a relative maximum at 5, and the relative maximum is 1. So the height y is what the maximum is, and the position x is where the maximum is located at. Okay, so from there, let's talk about the absolute maximum or the global maximum. Again, the word absolute and global here means the same thing. And so the global maximum here is going to be the highest point possible for our graph, the absolute highest point. And you can only have one absolute maximum. So in this case, our absolute maximum is 3, and it can be found at -2. So we're going to say that our absolute maximum point is -2, 3. Let's do the same thing with the minimum. So if you look for all the valley in our graph, you can see that you also have two relative minimum. Now, on the left here, since the arrow goes down forever, that's not actually a relative minimum because minimums needs to be point. Since we're going down forever here, we're not reaching a precise point, and so that's not going to be counted as a relative minimum. And so we're only going to have two relative minimum. The first one is going to be located at 2 and 1/2, and it's going to be -1. And our second relative minimum is going to be located at position 7, and the value for that minimum is going to be -3. And so if we now talk about our absolute minimum, our global minimum, if we look at our graph here, what is the lowest point possible? As you can see here, you cannot say in this case that your lowest point possible is going to be at 7, -3, because although that's the lowest relative minimum, it's not the lowest point for our graph because we have this arrow on the left here that goes down forever. And so for our global or absolute minimum here, you're going to say that that does not exist just because you're going down forever, and that would be it. Okay, and so this is it for terminologies, and next time we're going to be covering even and odd functions. Alright guys, that is it for now. The link for this note is always going to be in the description below. If you like this video, don't forget to share, like, and subscribe. Also, follow me on my other social platforms on Facebook, Instagram, Snapchat, and Twitter at Franck's Note, and I will see you in the next video.